Hello guys, welcome to another hands-on tutorial of OpenCV using Python. And in this particular video, we will be learning that how can we perform warp perspective on our images as well as the video object that you will be getting from your webcam. So what is warp perspective? So warp perspective is basically extracting the particular areas or particular regions of our interest out of the images or any video object. First of all, we will in this video we will learn that how can I extract the second card from left, that is the hearts of red card, out of this image, and then we will learn that how can I extract a particular area out of my webcam. So without wasting any time, let's get started. So first of all, we will be learning that how can I extract this card from this image using warp perspective in OpenCV. First of all, I have to load my original image. So in order to load my original image, I'm going to use my imRead method, and inside this I have to pass on the location of my image, and I'm going to store the image array inside a variable that is named img. And then in order to warp my image, I have to do a 4-step process. So the first step is to define the 4 corner points out of my source image. For example, in this image, if I want to extract this first card, I have to get the coordinates of that particular area. For example, this, and this. And then I have to give the coordinates of my final output, that is the how I want the extracted image to be presented on my screen. And after that, I have to perform 2 steps that will be related to transforming my image for warping, and then I will simply show my image. In the first step, I have tried to get the coordinates of my image. If you don't know how can I get the coordinates of my image, you can simply use any photo editor tool. For example, if you're on Windows, you can use your Paint or you can use Photoshop in order to get the corner points pixel locations. For example, in this photo, if I open this photo using my MS Paint, you can see that since I want to extract this second card, so if I bring my cursor to this corner point, you can see on your lower left corner of your screen that it is written about 85 and 30, and this location is about 150 and 30, and then this location is also about 150 and 126, and this location is also something about 85 and 125 pixel. So what I've tried to do is I have tried to give approximate locations. This is my first corner point, this is my second corner point, this is my third corner point, this is my fourth corner point. So this will be the coordinates of the particular area that I want to extract from my image. And then I'm going to store these in a variable whose name is PTS1, that is acronym for points1. After that, I have to perform my step number 2. In this step, I have to define the location of the points of my output image. So you guys must be knowing that in case of cards, the height is generally bigger than the width. Height of a card is generally bigger than a width. You can see from this image also, the height is bigger than the width. So I searched the internet and looked for a approximate ratio of the width and height of cards, and I wrote it here. So I tried to describe that the output image should have a width of 250 and a height of 350. After that, I defined my points too. That is the location of the points of my output image. That is the location of the points of the second card, that is a card of hearts, to be displayed on the screen. So I gave my initial position to be 0, 0, and then I gave the width, then the height, and then width and height of my image. After that, I tried to form a matrix. If you are confused and why this is 0, 0 and this is 0, so let me clear that. So in step number 1, what we did was that I had an image and there were 4 cards, and I tried to get the 4 corner points of the image that I want to extract. Since I want to extract this particular image out of this whole image, I got the 4 corner points. Then what I did in step 2 is I tried to give the locations of the points, the 4 corner points of this extracted image. So now I want to extract this image in a separate window. So in this window, I want to give the locations of this image. So I gave the location of the points. This was 0, 0, sorry, this will be 0 comma 0, and then this will be some width comma 0, because here the height is 0, and then I gave this 0 comma height, and then I gave this width comma height, just like this. 0 comma 0 for my initial point, width comma 0, 0 comma height, then width comma height. Now what will happen is that in my output image, since I gave my initial point to be 0 comma 0, and then my width comma height, then my 0 comma height, and then width comma height, my output image will be displayed like this. From this image, I extracted this image in a separate window to be displayed something like this. So this is what warp perspective is doing. Now I have to perform step number 3, that is to get my perspective transform matrix. I try to get a matrix by applying the get perspective transform method, and in this method I have to simply pass my 2 points. The first point was the locations of the image to be extracted from my source image, and point number 2 is the points that you get from step number 2. After that, in step number 4, you have to simply get your final image output by using the method that is warp perspective. And inside this, you have to first pass your original image, and then you have to pass the matrix that you got from step number 3, and then you have to pass the width and height of your final image. Now, once you run the code, you can see that this was my original image. This is my extracted output image. So this is how you can perform warp perspective on your images. Now we will be learning that how can I perform my warp perspective on the video object that you will be getting from your webcam. So in case of webcam, you have to simply first turn on your webcam by using the video capture method and pass 0 if you are using your default webcam. And if you have more than one webcam, you can simply pass 1, 2, 3, or depending upon the ID of the webcam you are using. And then you have to create a loop. If you are confused that why I have created a loop, then you can check out my video on how to open or read video object from a webcam using OpenCV. In that particular video, I have clearly explained the working of this loop, and for your sake of simplicity and for your ease, I will be giving the link of that particular video in the description also. So if you are confused, then please check that video out first. So I have created a boolean, that is success, that will give a true or false, and then I've created a variable that is frame, that will basically extract the frame by frame information of my video. All of you must be knowing that video is basically fast moving images. If many images are moving in a very short period of time, then it appears to us in form of a video. So I am extracted that particular image out of that video. Now I will be following my 4 steps, that is defining the 4 corner points of my webcam. And here you don't need a photo editor. I have in case of webcam, you basically don't need any photo editor, so I will be removing this line. And then you have to create the 4 points of your webcam. After that, you have to define the location of the points that you want to extract out of your webcam. So I have written any random points, 330, 330. You can write anything else depending upon the area you want to extract. And then in the step 3, I created a matrix by simply passing these 2 points, point number 1 and point number 2, which I got from step number 1 and step number 2. And then in step number 3, I simply used the warp perspective method and passed my frame, and then my matrix, which I got from step number 3, and then the width and height that I want to extract, which I have defined here. You can define it here by hit and trial depending upon the area that you want to extract of your webcam. And then I can simply run my code by pressing Ctrl Shift and F10 or by pressing the green triangular icon present on the upper right corner of your screen. And before running, let me explain this also. So this code will help in breaking my webcam. So whenever I will press Q button on my keyboard, my video object will break. So if I run it, then I'm getting an error. Why I'm getting an error? Oh yeah. So since I'm already using my default webcam for recording, that's why I'm getting an error. So if I turn this off, I have to simply close this one. I'm going to delete this one. Yes. Now my video object is closed. Now if I run it, most probably I won't be getting an error this time. Now if I run it, you can see that this is my source webcam, that is the actual webcam object, and this is the area that I extracted. So I extracted basically this area from my webcam. Okay, I'm looking very ugly, more uglier actually. Now if I want to close this, I will be pressing Q. So if I decrease my height a little bit, or suppose I'm going to write here 30 and my height is 330, and now if I do this, you can see that my height is the same 330, but my width has decreased and I am looking even uglier. Okay, so let me, I don't know what I'm doing, I'm just randomly checking out different values. You can also try to do the same. Now if I run it, yeah, it is much more better than the previous outputs. So yeah, you can check this out. I don't have any particular area that I want to extract, so I'm giving random values. But if you want to extract particular regions out of your webcam, then you can simply do so by hit and trial or by using any of the online tools. So that was all for today, guys. In this video, we learned about how to perform warp perspective on our images and the video object that you got from a webcam. And similar to webcam, you can do the same for video objects also. And that was all for today. So we will meet in the next video. Until then, bye bye.